Hey guys, it's me, Miss B. Today we're going to be talking about how to solve and inequalities. Okay, so first thing we're going to do is let's go ahead and do this quote unquote bell ringer. I'm just going to graph 4 and -5. So when we do that, just like on our last notes, we'd have an open circle on 4 pointing to the left. For 5, open circle pointing to the right. Okay, if you need review on that, you can go back to 1.5 day 1. Okay, so there are two types of compound inequalities, but the definition of a compound inequality is a set of, well, that is a set of compound inequalities. It's going to be connected by and or by or. Right? And when we have a compound inequality with and, make sure you write that down. Numbers that meet both conditions are solutions. So this right here says the numbers between 5 and 4. Okay? Another way of writing this is x minus 4, x is less than 4 and x is greater than -5. Okay? So we could list an infinitely many solutions, but we'll just list the whole numbers. Okay, so we would have -4, -3, -2, -1, 0, 1, 2, and 3. Those are all the whole number solutions that are between 4 and -5. Okay? So if we were to test each of these numbers, like -4 for example, -4 is less than -4, and -4 is also greater than -5. Okay, you could do that for every single one of these numbers. All right, so we're actually going to go through and determine whether these are solutions. The way we're going to do that is by plugging and chugging. So let's go ahead and start with our first one here. So we have x is less than 15 and x is greater than -3. So let's plug -4 in to see if it's a solution. And it has to be true for both of them. So 4 is less than 15 is true, and -4 is greater than, oh wait, I didn't do that right. -3 should be this number here. -4 is greater than -3 is false, so A is not a solution. All right, next up, 13. So we have 13 is less than 15, and 13 is greater than -3. 13 is less than 15, that's true, and 13 is greater than -3. So B is a solution. Let's test 0. 0 is less than 15, and 0 is greater than -3. This is true, and this is true, so 0 is a solution. Finally, test 17. 17 is less than 15, and 17 is greater than -3. 17 is not less than 15, so that's false. This is true, but it doesn't matter, so D is not a solution. Go ahead and do the next one on your own. All right, so there was only one solution to that one, and this was C. C is the only number that is greater than 28 and less, 29 is the only one number that's greater than 28 and less than 31. Right? Next up here, we can say that and inequalities can be combined into one big inequality. So if we were to write -2 is less than x, -2 is greater than x and x is greater than -5, we can write it as negative 2. That's not right. I've got them switched around here. So negative 5 is less than x is less than negative 2. So we're free to put these on a number line. Doing it backwards again. Negative 5, negative 4, negative 3, 2, negative 1. So if we were to do negative 5, it would point to the left, and negative 2, it would point to the left. I should have said right before. Okay, so this overlap area where there's both blue and pink is a solution. So as you can see, that's between negative 5 and negative 2. Notice that this is between negative 5 and negative 2 as well. So even in the equation, it shows that x is between those two numbers. All right, and then when we separate it, what we're going to do is we're going to look at the two different parts. So notice we have 14 is less than x. We're actually just going to, oh, wrong thing. We're actually just going to write that. So 14 is greater than x. I said that wrong. It should be greater than x is our first part. And then our second part is going to be the second half of that. X is greater than 1. Of course, we want to write it so x is on the left, so go ahead and do that. So we have x is less than 14 and x is greater than 1. If we were to graph that, here's 2, 4, 6. That's a lot of work. We don't need to graph it all the way. We'll just put 1, 14. The way we would look at that on the graph is like this, a barbell. Okay, so when we're solving a compound inequality with and, here are the steps. Step 1 is separate. Step 2 is solve. Step 3 is combine. Some of you might be able to skip this step, but I wouldn't suggest it. I'm going to show it every time. Okay, so step 1 is separate. So I'm going to separate it from negative 2 is less than or equal to x minus 8 and x minus 8 is less than or equal to 10. Step 2 is solve. So I'm going to add 8 to both sides. We get 6 is less than or equal to x. And then on this side, we're going to add 8. So we get x is less than or equal to 10. And then step 3 is to combine them again. So we get 6 is less than or equal to x is less than or equal to 10. So that right there is our solution. So go ahead and do the next problem on your own. So step 1, we want to separate. So we get negative 6 less than 3x, and 3x is less than 12. To solve, we divide both sides by 3. And we get negative 2 is less than x. And we get, on this side, divided by 3, x is less than 4. And then step 3, we have to combine it. So we get negative 2 is less than x. I write it in pink. I don't like this yellow very much. Negative 2 is less than x is less than 4. Here, Joe. Come here. Sorry, Joey's up here. All right, go ahead and do the next one. All right, what you should have done is separate. So 4 is greater than x minus 5, and x minus 5 is greater than 2. Add 5 to both sides. We get 9 is greater than x. Add 5 to both sides again. X is greater than 7. So then we get 9 is less than x is less than 7. I'm sorry, 9 is greater than x is greater than 7 as our answer. All right, that's all for today, folks. I think.